Yeah, I'll pop in like once in a while, but when I'm done with my big baby.
Okay.
Okay, thank you.
Sure. See ya. Okay. So I think we're recording at this point. So anything that you
Okay.
say is documented. So.
Okay, I'll mute.
I'll mute.
Okay. All right. So I wanted to say, first of all, welcome to everybody. It's good to see you all. So hope everybody's doing well. And what are we in week 3 of classes of isolation and distance learning? Ooh, sounds like fun, doesn't it? Not really, but we'll deal with it.
Is that short?
Yeah, really. So, and I think we only have about what, like 4 weeks left or 3 weeks left of the semester. So we're
That's right.
Yeah, we're getting there. So I guess I wanted to start by asking if there were any questions or any thoughts about last time that anybody wanted to share. And then we can go ahead and get started after that with the bulk of what we're doing today. So I'll open the floor up to any comments, suggestions, questions, anything like that from last time.
It was great. I learned so much. Partial fractions so useful.
Oh, yeah.
Cap2 and of course derivative integrals.
Oh, yeah.
Absolutely great. Thank you.
Oh, sure. Thank you, Sandy, for the great feedback. All right, guys. So I guess we'll go ahead and get started then, and we'll start with the conditional statements. And essentially, when we talk about conditional statements, the only one I ever really use is the if statement. I don't use the case statements too often for anything. So I'm just going to illustrate a couple basic examples as to how to utilize the if, the else statements. And then we can move on to be able to use those conditional statements in tandem with the looping. So I'm going to define 3 variables that are symbolic. I'll just say X, Y, Z. I'm going to clear all as well. All right. And we and I hope everybody has the agenda with the problems that I sent out to you guys. And what I'm going to do is I'm just going to work through each of those with you guys just to illustrate how they work. And the first one's a really simple example. The program prompts the user for 3 numbers. And then the program will find the average of the numbers and state if the average is less than, greater than, or equal to 70. So this could be a good benchmark if you're trying to write a program for grades and you want to figure out if the average is greater than or less than 70 as a benchmark of C. So I'm going to start by saying A is going to be equal to input, and we're just going to say enter the first number. Not fist number, first number. And I'm going to do the same thing. I'm going to suppress this. And I'm going to say, oh, I'm not going to say anything. And I'm just going to change these to B and C. And we'll say second and third. And I'm just going to say AVE equals A plus B plus C divided by 3. And now that's stuff that we did last time. That's easy. So now what we're going to do is we're going to do the conditional statements. And we're going to say if av, and what I like to do is I just like to use parentheses because that way it knows that it's reading that entire statement. So if average is less than 70, we're going to say f print f the average is, I'm going to say percent %f and is less than 70. All right. And I'm going to do a backslash n. And you guys probably remember last time, backslash n means you're going to the next line. Right? And then we could just do an end. And I'll show you how to do this with an else statement as well. Okay, so I'm going to show you guys 2 different ways to do it. And then I'm just going to copy this, and I'm going to say if average is greater than 70, then the average is percent %s and is greater than 70. And then finally, and remember last time, if you don't want to do assignment, if you want to do a Boolean test to make sure true or false, you have to use the double equals, okay? So you could say the average is 70. All right. All right. So that should execute, hopefully. All right, but that's our pretty short program to be able to do those. And I will post this code. I don't, did I ever post the other code or send it to you guys? Okay, so I'll make sure I send that. Let me make a note really quickly. So I do that. I have my list of things to do. So I need to post the code from 1 and 2. But I did post the link, and I think I sent that to you guys, right? Okay.
Yeah, you did post the link.
Okay, I finally did something right. Good for me. All right. So I'm going to execute this. We'll see how it goes. All right, so we have our first number. Let's just make this really easy. Let's just do 1, 2, and 3. All right. And it just says the average is blank. Oh, I know why. I never put in the last parameter, did I?
No.
So I didn't say comma AVE. Okay, that would be helpful, wouldn't it? To get a parameter out, you probably have to put a parameter in there. Duh.
Oh, what a surprise, right?
Yeah, I know. All right, let's try that again. All right, so 1, 2, and 3. All right, so the average is 2, and it's less than 70. Ooh, shocking, right? All right, I'll try it again this time to make it equal to 70. So let's try 69, 70, and then 71. Okay, and the average is 70. Okay, so that's a pretty easy way to do it. I know a lot of times just for my, I guess for my personal, to make it easier on me to find out where errors are, I always like to use separate if statements. I don't like to use else if. Sometimes it gets difficult to find the logical errors if you use an if and then an else if statement, okay, on occasion, but that could occur. All right, now I do want to use an else if just to show you guys how that works as well. So I'm going to percent all of these out. Let me go up here. So I'm going to percent, oh, I'm not going to do anything, apparently. All right, so let me percent this. All right, so bear with me. Sorry, my hands are big and the keys are small. All right, now I'm going to do the same thing, but I'm going to use else if statements this time. So I'm going to copy this first statement. Okay, so if average is less than 70, we're still going to print that output. Okay, so that's not changing. But then we're going to say else if average is greater than 70, we're going to fprintf.
All right.
And this time is greater than 70. And then the last one is just an else. So else, we're just going to fprintf the average is 70. All right. So that would be, well, hopefully that's the syntax. All right. So it's a little bit more concise than what we had before. All right. Format might not agree. That's fine. Oh, that's right. There is no, we don't need anything after that. Okay. So now this one's a little bit more compact than the previous. All right. But again, it is susceptible more to logic errors. So I try not to use the else if statement. So I'm just going to run this. First of all, so let's do 1, 2, and 3 again. Right. And the average is 2, which is less than 70. Oh, not shocking. Going to run it again. And remember, what did we do last time? 69, 70, and 71, I think. Right. And the average is 70. Okay. So this is 2 different ways to be able to work the same problem. You guys could imagine if you're doing something that has a lot of different cases. So maybe you want to assign a letter grade to a number grade or something like that, where there might be 5 or 6 different outcomes. This is probably going to be a little more efficient than the first way. But I think the first way, again, isn't susceptible to logic errors. Okay, so any questions I can answer about basic ifs and else statements before we go on and try another one?
Not really. I have an example to send you, and I forgot to do it the last time, which is why you use case statements, switch cases, and that usually has to do with large tables where you're switching stuff back and forth.
Yeah.
And
Well,
I have a very good example of that.
Oh, cool. If you could send it to me, that'd be great, Bill.
Yeah, I will.
Just to let you know, it's funny that you said the word switch, because a lot of computer languages flip case and switch.
Yeah.
Excel actually uses switch. So did you do that on purpose?
Yes, because that's what it's called.
Oh, nice. Good job.
So, I mean, literally, that's what it's called.
Nice. All right. All right. A second example. All right. We're sending everything out. So the next one, a little bit more applicable in our calculus courses. So a program is to select from a menu of 3 applications. So find a derivative, find an integral, or plot a function in 2 dimensions. The user will enter D, I, or G for graph, and then the program performs the operation. Now, if the user enters anything else, it's not going to do anything. It's just going to terminate right away. All right. So it doesn't have error checking in it yet. Okay. I'll get to error checking. So first of all, we have to get the prompt from the user to be able to determine which of the 3 choices they want. So let's just say choice is equal to input. And we're going to say enter D for derivative. And let's just say derivative with respect to X, just to make it really basic for us. We could do it if we wanted a specific variable, but I'm just going to try to make it just a simplistic example. I is integral with respect to X, or what do we say, P or G for graph of a function in 2 dimensions. Well, we'll just say graph of a function. All right, so I guess it's a choice. All right, and then there's we're going to ask for the polynomial or for the expression. So we're going to say, and I think we might have to call that, we're going to have to make that a symbolic variable. So I'm going to say that might be equal, I was going to say exp, but that's not a good idea. So let's just say expression. I don't think expression is a keyword in MATLAB. So we're going to say expression is going to be equal to enter a function in terms of X. So we're going to get that from the user. And then we're going to say if the choice, so if our choice is equal to D for the derivative, okay, then all we're going to do is just find the derivative and print that out. And we should use a double equal. And also notice that I put the apostrophes around the D because it's a character type that we're looking for. Okay, so if it's a character type, you have, or even a string, you have to use those accents around it. Okay, otherwise it won't recognize it correctly. Okay, so if choice equals D, we're just going to print F. We're going to say the derivative is, right, and I'm just going to say %s. I want to print it as a string for that. Okay, and I'm going to say \n, comma, diff expression, okay, comma x. Right. So what that's going to do is that it's going to print out the derivative of whatever expression is with respect to x. Right. Now, else if, let's say choice is equal to I. We're going to do the exact same thing, except we're going to find the integral. So the integral is, and this time instead of int or diff, we're going to say int to make it nice and easy. Right? And then finally, else if, well, not finally, because we still have one more after that. Else if choice is equal to, what do we say, G, then all we're going to do is we're going to do easy plot. And we're going to easy plot expression. And then else, and then I think after that, else we could just print F. We could just print a new line, just so that way it goes down to the next line. So, and then it probably tells me it doesn't want an easy plot because it doesn't like it. I don't really care. All right. So I'm just looking over it really quickly just to make sure I didn't make any syntax errors. All right, but I figure one of you guys would catch it. Okay. All right, so let's give it a try. Let's see what happens. Oh. All right. So we have to, first of all, we have to enter our polynomial. I know I made that really long. Maybe I should make it into 2 lines. So I'll fix that in the next. But let's just find a derivative to make it really easy first. All right. So
That's you guys and not me, right?
yeah. So I'm going to control break out of here. Oh, shoot, I'm looking for the break key. That's not good. Okay, there it goes. All right. So, wonder what's going on with this. Anybody see anything that's not kosher?
I haven't got that far yet. I'm still trying to clean up my mess.
Okay. Let me go back. Go ahead.
Live script is helping me too much.
Oh. Percent all these out. Okay. So, let me try it again.
It may have to be something to do with the way you wrote your choice statement.
Yeah. I wonder if it's the string.
Could be.
Yeah. Let's try it again. Okay. So I'll try D. So undefined. Oh, you know what? I think I have to make those possible variables. I have to make those symbolic. I think I have to make
Possibly.
D, I, and G. All right.
You could also use menu, and there's some other choices for doing that, yeah, as you may be aware.
Let's try. Let's try D, I, and G. Try that one more time. See if that works. Nope. Let's see.
No way.
That made it a lot worse, I think. Let's try this. Oop, that doesn't work. All right. We try getting rid of the accents. Although I don't think that's going to work. Let's see if that works. Nope. Okay. Oh, I wonder if we have to make choice a symbolic variable. Oh. I'm trying everything I know. If this doesn't work, then
There's a couple of different ways to do it. One of them is to use something called menu.
okay.
And
Yeah.
that'll give you numbers back, of course, and then you have to say what the numbers are. In fact, what it should do is print out a little thing on the screen you can choose, like a pop-up.
Yeah, I saw that. Okay. What I'm going to do is I'm going to take a look and see if I can fix this, and I'll post it for you guys. I should have worked through yesterday. I'm sorry. I just ran out of time, and I was just assuming that I could do it. Oops, bad assumption. So, but I will post. I'll fix it and post it online for you guys.
I'm not sure if this is right, but does the first choice have to be equals equals input?
Yes.
Because I think it's going to be assignment, but I'll give it a try. It couldn't hurt.
Actually, no. Yeah, I have to look up how to do input. Geez.
Didn't give any error at the time.
Give me a sec here. I gotta.
Okay.
That book on this.
Okay.
Because I was trying to write as fast as you were writing, Chris.
Oh, sorry.
And
Okay.
I'm down to the else statement, but I haven't gone through and attempted to fix the code here.
Okay. Well, I'll try to figure it out once we get off, and then I'll see if I can post it for everybody. It's probably like a parenthesis or the string or something like that, or a data assignment that I'm not sure of. But all right. So
Doesn't that allow you to enter the integral or something now?
One more time.
Can't you go ahead and enter the integral or whatever now, since it's got the next line here for you? Or is it automatically jumping to the next line saying it doesn't know what to do?
Yeah, so what it's doing is it's reading choice, but it's not doing anything after that. So
gotcha.
So I get here, and it's doing the, oh, check this out. I bet you if I put the word input next to expression,
that might have something to do with it.
That might have been helpful, wouldn't it?
Yeah.
Oh.
Well, it's always the little things, right?
Yeah, really.
Yeah.
Oh. I feel so
sketch. I mean, I'm doing this in
hey, finally. Okay. So I know. All right. Let's try a really basic function. Let's try x squared and see if we get the derivative out of that. All right. So the derivative is 2x. Yay. It took us all that time to figure out the derivative of x squared is 2x. All right. Let's try integral this time. Let's try 3x squared. Success. All right. And then finally, let's plot x squared. Oh. Enter a function in terms of x. Oh, let's see. So it didn't do anything because I put in x squared as the choice. So it just went there. So that's good that it's actually not doing anything. So one more time, let's try to graph. All right, so here's our graph G. Let's try x squared. And I might have to share it, but it did come up for me. I have to share this with you guys because it's a different window. And you guys probably know on Zoom. But what happens is if I share the screen, this is the output I got from it. So can you guys see the graph now of the parabola? Okay, cool. Nice. Okay. And you don't see the code, though. All you see is the parabola, right, guys? Okay, cool. I'm going to get rid of that. Oh, there you are. All right. So now we're 2 for 2 on programming assignments. It was almost 1 for 2, but whew. All right. So guys, that was just a basic overview of how to do the decision statements. All right. And there are other decision statements, but you can always use an if-else to pretty much do everything. So I'm going to percent these out, and we're going to move on to looping. That sounds like fun, doesn't it? Maybe not. All right. So 2 different types of loops that I'm going to go through, a for loop and a while loop. And a lot of times in MATLAB, you can actually do the looping just by assigning a vector. All right, so you could do it that way. In fact, later we're going to show you that you can actually graph by using a vector instead of the easy plot function, which some of you guys might already know because that's the older way of doing it before MATLAB got the symbolic kit into it. But I'm going to start with a pretty basic loop. All right, so the first one I have is a user is prompted to enter an integer n, and we're going to write a for loop to be able to print out the first n perfect cubes. Okay, so first of all, we're going to say input, or we're going to say n is going to be equal to input, enter an integer, and we're just going to get the integer. And we're going to say for I equals 1 colon, or I'm sorry, for I equals 1 colon 1 colon n. And I'll explain what that does in a moment. We are going to print f. And I'm just going to print percent n, or I'm sorry, percent d, because it's going to percent d, remember, that's an integer type. And since we're getting perfect cubes out of this, all we're going to be doing is just getting a bunch of integers. I'm going to do a couple spaces, so there's some space in between there. And I'm going to say, comma, n cubed. Okay, I'm going to end this. And then the last thing I'm going to do, and this is merely for formatting, I'm going to print f a couple returns. All right, so that way you're not bumping up against the end of that. All right. And let me suppress this so that way MATLAB's not unhappy with me. So let's see what happens here. The worst I could do is crash, and it takes us 10 minutes to figure out why. Not that that happened already. So let's try 6 perfect cubes. Oh, and gives us 216. Oh, okay. It should be I cubed. I see the problem. So I did n cubed. That should be I cubed. All right, sorry about that, guys. Otherwise, I just keep getting the same thing. So let's run it again. And we'll do 6. All right, and there we go. We get the first 6 perfect cubes. All right, lots of fun because we don't know the first 6 perfect cubes, do we? So, I don't know. What do you think? 100? That might be fun. There we go. Unfortunately, you have to scroll over to get to those last few 100 perfect cubes, but it's actually pretty cool because what you could do is you could make like a perfect cubes table for your student using MATLAB, and after every 10th iteration, if you did like a modulus function, you could have it do a return, so you could kind of get like that table or even a multiplication table if you wanted to. So, so this is a pretty good basic programming thing. I taught an intro programming class once, and that was an exercise I actually did for my students. One of the final ones is that they had to create a multiplication table, and it used if statements, for statements in it. So it was pretty cool. The students didn't mind it too much. It wasn't meant to be too difficult. All right, so that's a basic for. I'm going to show you guys the same exact thing with a while loop. Okay, so we're going to, again, now what we're going to have to do this time is we're going to have to do I equals 1. All right, and this is usually called priming the variable, which means that you just have to instantiate the first iteration so that way it knows that that's basically, that's their counter. Okay, so I'm going to put a percent next to this. This is our counter to be able to go on to the next iteration if you're using a while loop. We're still going to get the value from the user. Okay, so we're going to say n is going to be equal to enter the integer, and we're going to say while I is less than n. Okay. Actually, less than or equal to n, because we do want it to print out that nth integer as well. Okay. What we're going to do is we're going to print out I cubed, or we are going to print out I cubed. Okay, so we're going to print out I cubed, and then we're going to I is going to be equal to I plus 1. Now, what that does is that means now you're on the next iteration. Okay, so now it's just increasing the counter by 1. All right, we're going to end, and then I'm going to do this fprintf statement again, so that way we're not bumping up against the cursors for the syntax. Okay, so that makes sense to everybody, guys? Any questions? The while loop's a little bit more cumbersome than the for loop. I always like for loops if I can. So let me go ahead and execute it, see how many mistakes I made. It's always fun. All right, so we had 6, so we'll use 6 again. Oh, I'm getting better with programming.
There you go.
Yeah, there we go. I'm starting to learn. All right. We did 100 last time. So let me see if I could do 100 again if it works. And we had like 97,000 for one of them at some point. So there we go. Yeah, that looks good. So both of those loops do the exact same thing. Usually, go ahead. I'm sorry.
Yeah, I was going to say that's good. What I known from programming professionally, we tried to avoid using for and while loops, and that was in our documentation not to do that without special permission.
Oh, really? Wow.
Oh, yeah, because you can screw it up very badly, and you'll never find the errors.
Oh, okay. I see what you're saying.
And so we had always insisted that in professional programmers, if possible, to use case statements for that reason.
Oh, really?
Yes.
Ooh.
Because that is something you can debug quickly, and you can prove in your code that it's tractable and it won't hang up the CPU.
Oh, that's cool.
But, you know, I teach the students anyway, and I just tell them when you get out in the real world, you may end up with, in your programming guide, and your style guide from your company or whatever, that that's not going to be allowed.
Yeah.
So
I've never encountered that, Bill, but that's pretty cool. That's good knowledge for me to pass along to my students.
yeah, I tell them, as I'm going to say, I'm going to teach you it anyway. You just have to be careful with it. And the while loop is worse than the for loop.
I do agree with that, yeah. And I was going to make that statement that generally a while loop is a little bit less efficient than a for loop because of that counter. It uses a little bit more memory, although nowadays it's negligible.
Yeah,
So,
it's not the memory issue. It's usually the logic mistake issue where the thing never exits.
yeah, that too. Yeah, with that while loop. Yeah, the for loop will exit eventually because it only goes, it's mostly a predetermined number of iterations. Whereas a while loop's based on that sentinel, and oh boy, that may or may not ever happen.
What normally happens is the older programmers, if you go back to Fortran and those things like that, what they used to do is they used to decrement or increment the counter within the loop. And in MATLAB, you don't do that. You put it on the outside,
Yeah.
with the statement you had up there. And so every once in a while, you see it in students' work too, as they'll attempt to increment or change the counter in some way inside the code that's executing.
Yeah.
And that really screws things up.
Yeah, it does. So lesson learned, loops are dangerous.
Loops are dangerous, yep.
Although I couldn't get my if statement to work earlier. So.
Yeah, well, there's that problem too.
Yeah. Well, speaking of that problem, unfortunately, so essentially what we're going to do is we're going to be using that same exact code, except now what we're going to do is we're going to force the user to put in the correct input, either D, I, or G, and if they don't, it's going to print an error message. Okay, so here's how we're going to do that. So I'm just going to cut that code that we used before. And I'm going to get rid of all the percent signs. So bear with me as I fumble through this. All right. Now, instead of this last statement, else, I'm going to get rid of that because we don't want to say that. Okay. We're going to get these. And we're going to just go ahead and do all these, everything as noted before. And if for some reason, so we're going to say while we could do it this one of three ways. We could say while choice not equal to D, and then or, so to get or you use the double line. At least I think it is in MATLAB. If it's not, okay. That's what I thought it was, but it's got the underline under it, but I think it's just because I haven't closed it out yet. Okay?
That's correct, yeah.
Okay.
So it's not recognizing those yet as logical constructs.
Got it, yeah. Okay. So while choice is not equal to I, not equal to I, or I'm sorry, what D, I, or G. What we're going to do is we're going to print F.
You don't need the last double pipe.
Thank you.
In that statement, that's going to create a
Good
problem.
catch, Bill. Thank you. Yeah, that would be a syntax error. We'll say invalid input, and then we'll /n. So we'll go to a new line. We got to close that out. All right. And then we're just going to go ahead and just ask the user again to input the same stuff. All right. So now this one we have to use a while loop because it's non-numerical. So we can't use the for loop because we're not really doing a counter. And we don't really care how many times it takes. We'd like the user to do it on the first time. Right? Then we're going to end it. And it's just going to keep going through that. Okay, so if for some reason you're not entering I, D, or G, then it just keeps going through that logic. All right, so let's try it out. Let's see what we get. Line 60.
Invalid use of operator.
Oh, I see. I lied to you guys. The syntax is not equal. So in MATLAB, it's this tilde instead of exclamation point. I thought it would be the same because MATLAB has the compiler of C++, but or at least
Not quite.
Go ahead, Bill.
Not quite.
Yeah,
Close.
close. Right. I think the platform is C++ based, but yeah. All right. So let's try that. So this is the not statement. Not equal. So let's try it again. See what happens. Missing an end. Oh, I know. This end. One more time. All right. So what I'm going to do first is I'm going to try to give it a valid input. So let's try I, because integrals are always more fun. All right. Enter a function in terms of x. Let's try log x. That's a fun one. Invalid input. Well, that's not good.
Did it work for x squared?
Let's try D. Oh boy.
So it's not your while loop that's screwing up.
Yeah. It's for some reason that it doesn't like something going on here.
Chris, do you need to get rid of the expression from the line above because you don't want it to go any further if you put the wrong input?
So basically clear the variable choice. Is that what you're saying, Paul?
I was saying leave choice, but get rid of expression on line 58
Yeah, we
so that
really
the while loop only works for that, I assume?
Yeah, I would put it below all of that stuff.
Yeah. So like that, is that what you guys are suggesting?
Something like that, yeah.
Okay. And then we can get rid of this, right? This expression. Because we don't even care about it if it's the wrong choice.
Yeah, you don't want to be entering it in there.
Okay. Let's give that a try. Couldn't hurt. Better than what I did. All right. So let's try I. Enter.
Well, okay, so you need choice as input. Enter D for X. And,
Doesn't like anything.
well, I think your choice statement, something's wrong with it.
Yeah.
I can't read the end of it, but it doesn't look like it has the later, Karen. Okay, after lunch, okay?
You need the double equals.
Okay, so you've got a statement. And
I meant for like, you've got D here and...
yeah, it's got to be a single equal. It's an assignment operator for one thing.
Yeah.
Okay.
There. So that's correct.
But right here,
I think that's okay too. I think what does choice look like when you run it? Does it just, can you put a breakpoint and see what choice comes out to be?
so
Something
I
in?
ran it one more time and just put the breakpoint right here.
Yeah.
Oh, I guess I have to get out of it. Hold on. Okay. And then Bill, to put the breakpoint, you just right click in there, or?
Yeah, you right click on it. Yeah.
Okay.
Yeah.
Okay.
I mean, it's very similar to C++
Yeah.
that way.
Okay, so that's what it has. So should I go one more line down?
Yeah, go one more line down.
Okay.
You can right click it and you can get rid of the breakpoint.
Yeah.
There.
And then right here, I guess we want
Move it down there or something like that.
Okay. Okay.
So that looks okay, right?
Yeah. So I'm not sure what's going on with that. Now, That shouldn't be and.
Well, the choice is I have to think through the logic of that. So
yeah, I was just trying it to try something else. But
see, well, the choice is that, that, and that. Well, yeah, it's and, I believe. Okay, so something still screwed about it.
so let's try that. Well, it got to the loop. Okay.
Okay, so that was what the issue was.
Okay. Logical fallacy. Oh. All right. So we tried integral last time. Let's try graph. Well, no, you guys can't see the graph. Let's try derivative, see if that works. How about x to the x? That's a fun function, right?
Yeah, it always is.
Yeah. There we go. It did it. Very nice. All right. Cool. Let's try something that's not one of the choices. So let's see. So I'm going to try y. Okay. Oh, I know why. No pun intended. I know why it did that. It's because y is not a symbolic variable.
Well,
So,
actually, that brings up an interesting question. How do you've got all this stuff defined with symbolic variables. You've left the user a choice of anything, literally.
true.
How do you, is there a way to say that choice is now a symbolic variable?
Yeah, that's true. I bet you we could assign it somehow. But remember we defined x, y, and z as symbolic variables?
Yeah.
So I just typed in y, and it did exactly what we wanted. And I think z would do the same thing. It doesn't give like that red error message. So,
Okay.
so I think other than the fact that that we don't have symbolic variables defined for every possible variable, at least the code does what we want it to do this time. Okay. I think I'm done with this example. I don't ever want to see this one again because it's the only one so far that's giving me any trouble. So I'm going to percent this thing out and no boss.
From a, let's say, professional programming viewpoint, the reason why you would not use a while there is because maybe the user can input anything and would just lock up the computer forever and walk away frustrated. What you want to do is have some kind of timer for that case where that happens where it would kick out.
Oh yeah, that's a good point. I'm going to make a note of that. So if I ever do this again, I can show my class how to do the timer.
Yeah, because you need a timer to say, hey, look, you know, you're done.
You got Paul's dog on the screen too.
Yeah.
Paul, who do you got there? All right.
That's Hella.
Oh, gotcha. I can't tell them apart. Sorry. I don't know how you do, but no. I guess you've lived with them for a couple of years now, so you know.
They also have different colored collars.
The Hun.
Yeah. Nice. All right. So one more example that I'm going to take a look at with you guys, and this one's a fairly long one. Being able to enter the function to find a 0, give an initial guess, and then an initial error. And the program is going to use the Newton's method to be able to approximate the zero until the error between the actual and the Newton's method is less than the user-defined error. And so we're going to print basically a table to where we print the iteration, we're going to print the approximation, and then we're going to print the actual error. Okay, so a little bit long of a problem, but certainly one that your class, all of your Calc 1 classes could use. And not only that, but you can use it in any engineering classes to approximate roots if they don't have their calculator. Certainly in physics, they need this sort of thing. So, so let's go ahead and we'll start by first getting the error from the user. So error equals, enter an error to approximate.
Yeah, that'll actually help in linear algebra too, because you have to figure out the roots of things on occasion.
Oh yeah,
Polynomials get ugly.
yeah they do. Yeah. I guess we need a polynomial to actually work on, or at least a function. Excuse me. So yeah, polynomial would be great, but so let's say the function. Oh no, function's a reserved word. So let's say fun is going to be equal to enter a function to find or to approximate the 0, 4. Sorry if that's not correct grammar. I don't get graded on grammar. So we have the function, we have the error, we need initial guess. So we're going to say guess is going to be equal to enter an initial guess. All right. Now with this one, you probably want to use a while loop because, and unfortunately, because it's contingent upon the error and the computation of that.
Yeah.
All right. So I guess the first thing we'd want to do is to get the first iteration to be, and we also want to get the solution as well, because the solution is going to be the actual. So let's say actual is going to be equal to solve. We're going to say function double equals 0 for x. That should do it. And when we say the function, we should say in terms of x, just to let the user know that we don't want a multivariate sort of thing. All right, so that should give us all the stuff we need at this point. All right, so now we're going to get the approximation. Okay, so now remember Newton's method, and I'm going to put the percent up here just to remind you guys. But Newton's method is the next iteration is going to be equal to the current iteration minus f at the current divided by f prime at the current. Okay, so that's our formula for Newton's method. So we're going to say our approximation, at least for the first iteration, the approximation is going to be equal to guess minus, we're going to substitute into the function. So we're going to substitute into the function, and we're going to substitute guess in for x. So this statement right here, subs fun x guess, that just means we're plugging guess in for the function in terms of x. And then we're going to divide that by, we're going to derive, so we're going to differentiate function, and we're going to subs into that. So we're going to subs into the derivative of function with respect to x. We're going to substitute for x, and we're going to get the guess out of that. All right, so that should be the approximation. Now, what I'm going to do is I'm just going to run this at this point just to see how we're going, how everything's going. So let me execute this. I'm trying to. Oh, obviously, we're stuck back up here. All right, so sorry. All right. And I probably need to define function as a symbolic variable. So let me go all the way back up. Actually, I could just do this. So we're going to say sims fun. All right. So let's try again. I think that'll do it. But then again, I thought the first time it would work too. All right, so line 60. Actually, error using subs. Expected input number 1s to be one of these types. So where are we at? It says line 60, but All right. Try one more time. So it's kind of worrisome that it's not even getting to the point where it wants to read the function. Shh. And I don't have anything. All right.
Yeah, I'd have to really study to figure out what went wrong there.
Yeah, I don't think anything's, unless I missed like a parenthesis or something, but I don't think I did. MATLAB's not yelling at me. Unless fun is a reserved word, but it's not saying it's a reserved word. Now I have to change them all.
You make it funk with a
Shit.
K. Function may be a reserved word.
Yeah. Yeah, function is, but funk is not. So let's try that.
So what you're saying is you can't have fun with MATLAB.
No, you can't. Oh, nice.
No, boo hiss.
It was actually pretty good. I'll give you that one, Bill. Huh. So guess minus subs. Let's see. I'm looking at the number of parentheses. So parenthesis, 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 parenthesis.
You're missing a parenthesis there.
We're at
Where you were. You've got diff, and then you got func, func x, another parentheses, then you got x guess and another parentheses. I guess so.
yeah. This I think these two parentheses. This one.
Okay.
And
Yeah,
one.
that's okay.
Yeah. So I don't think it's the parenthesis issue. It's weird. It's saying validate attributes. So in for subs, it's expecting. Huh. All right, well, how about this? This has worked on rare occasion. I'm going to shut MATLAB down, and I'm going to start it again, because I don't see what the problem is.
Yeah, oftentimes what I would do there is actually break that function apart
Okay.
as a series of test cases and look at each part to make sure it's doing the right thing, because it may not be.
Yeah. Okay, hold on a sec, guys. I have to start MATLAB again. And then I have to share the screen. Sandy, you're blue. Oh, now you're now you're a tree. Okay. It's starting. Okay, hold on a sec, guys. Now I have to go back and I have to share the screen again. All right.
Just a bunch of fun with these tools. It turns out Teams now has a background mode also.
Yes, I saw that yesterday.
And that's from the latest iteration of it. And they have a pretty cool Halos team from the Microsoft Halos game.
Oh, cool.
And I'm thinking about stealing it and putting it on this one.
All right, so let's see if it's, I'm going to go, like you said, Bill, I'm going to check each line. Let me get rid of that and see what's going
I
on.
just commented it out. I always tell people to comment that stuff out, not erase it.
Yeah.
Because I don't want to introduce additional errors when they're trying to fix it.
Yeah. Okay, so maybe what we could do is we could just split it up into multiple parts instead.
That's what I would do first, just to check out the parts.
So we'll say numerator is going to be equal to subs. We're going to say function, which is func. The old variable was x, and the new variable is going to be guess. And the denominator is going to be subs And we're going to take the derivative, diff, of func with respect to x. We're going to substitute for x, and we're going to substitute guess. All right, so I'm just going to run that.
Comment out the approximate. Just do that.
Yeah.
Let's see what happens. That's how I debugged some very complicated code the other day.
60.
So it doesn't like line 60.
And
For
85.
some reason.
And what's up to 60?
Nothing. Let's see if I cut that out. Let's see what will happen. I just cut it. I can paste it back. But it's commented. It shouldn't be a problem. Yeah.
Well, the comment lines aren't counted in the line count, you know.
Right. Oh, I see what you're saying. Okay. All right. So let's see if it's the subs. Okay. Huh.
There's the untotaled. What's untotaled? So it doesn't like 85.
Yeah. I don't know why. Error in. Huh. I don't think it's the double tell. So
Now, I think it looks fine from a functional viewpoint.
Yeah.
The question is, you have func coming in above that, and are you getting a variable to be put in? Are you getting a function there to be put in?
You know what's helpful?
Yeah, do that.
Yeah, that's probably helpful. It's the second time today.
Because it's looking for a function to evaluate. I realized what it was saying.
All right, let's try one more time. I'm so sorry, guys. Oh. Oh, the run is right below, like where I go to run it. It's literally like right on top of the share screen when I do
I
this.
tell you, we are all amateurs at this online massive video thing. Because I record every lecture now, and some of them you go,
Yeah. Hey, there we go. All right, so let's do 3x squared, and let's try the 0 is 2 for that, or 1, and we'll and all right, so it does go through. It does the first iteration.
good.
Yay!
Yay.
All right, so now we have to actually do the loop. All right, so now we're going to say while, and we have to compute the error, right? So error is going to be equal to the absolute value of, what are we going to say? What's it going to be? Approx minus actual divided by actual.
Yeah, I think it's that, yeah.
Yeah.
All right, that should work. All right, so we're going to say while error is less than, I'm sorry. Did I define error twice now? So this is given error. So let's call that user error. All right, so, and then there's actual error. So while user error, or while error is greater than user error. I know that's terrible coding it's terrible coding convention, but regardless. All right. So we're going to do the exact same thing. We're going to get the approximation. We're going to compute the error again. We do need a counter, don't we, guys? Because we need to.
For while statement.
What's that? Well, but remember, I think the problem asked us to print out the iteration number that we're on as well.
Okay, so you can put in a counter for that purpose, but.
Oh, right. Right, Bill. That's what I meant. I'm sorry. I should have been specific.
But it shouldn't be modifying a while statement.
Oh, right, yeah. So at least in this one. Okay. So let's see. So we get the next approximation. We get the error.
You could put, yeah, you start with that. That's fine. And you can put in the statement itself,
Yeah.
I equals I plus 1 or something. Or,
Yeah. We definitely want to print. We want to print these out too. So, but we'll get to that in a minute. So, I guess what we should also do is, so these guys, they're done. We don't need that because we could set the error equal to something huge to make sure it actually goes through the first time. Unless the user wants, you know, a 10 trillion % error for some reason, which they wouldn't. And we should print out the table, like the fprintf, like just the header for the table. So we're going to say we're going to print out I, and then we're going to print out the approximation, and then we're going to print out the error. And we can do fprintf again. Just do like a bunch of hyphens. All right. So now we can do fprintf. So now we're going to print out a %d. So that's going to be the iteration. We're going to print out a %f. That's going to be the approximation. And then we're going to print out a %f, which should be the error. And then we're going to go to the next line. And we're expecting I. We're expecting the approx. And we're expecting the error. All right. And I equals I plus 1. All right. So did I miss any inputs this time? Since it seems to be the only thing I consistently am doing wrong here. Of course, we can always just run it to see how it goes. I probably should suppress this approx. Okay, so let's see how it goes. All right, so anybody got a cool function we can try to approximate that doesn't have a wonky domain? How about
Sin x minus x squared.
Oh, nice. Good one, Paul. I was going to do exp minus sin x, but yeah, that'll work nicely. Okay. And error, let's just do 0.0001. Initial guess, say 1.
1.
Yeah, sounds like fun. Okay. So we need a control break.
Well, here's an interesting thing. It looks like the error is infinite there, and it's
Yeah.
not blinking.
Right. So do we make an error? Approx minus actual divided by actual. Are we solving the actual? Yeah, we got the actual up here.
But are you solving it down anyplace else?
Right, we only need it one time. The approximation keeps changing each time, but actual doesn't get reassigned.
Okay, so you got approximate. I mean, we got to take a function that we know what it is. This is the first test case.
Yeah.
You need a, after your fprintf with all the dashed lines, a \n
Yeah, thanks.
in there, just so that's why everything's offset.
Yeah. All right. All right, so let's try something easy like 3x squared. The only thing I could think of is maybe that function's.
It may blow up, who knows, you know.
Yeah, it might be not well behaved. No, it got worse. So it doesn't like this variable. It doesn't like this error variable for some reason. Warning, solution does not exist because the system is inconsistent.
Consistent. Ah.
So does that
You
mean?
have to normalize the whole mess. Okay, that's another issue.
Okay. Oh, let's say, let's try something. Let's try cos x. Say 1.
1.01. Okay, that looks okay.
It's better,
Better.
but it doesn't look like it's replacing
Not
the error.
converging.
What's that?
It's not converging on anything.
Yeah. Oh, I know why. Because, see this?
Yeah.
We're using func each time. We're not replacing it.
Ah, okay.
So it's the original function. That's why I did it outside the loop the first time. All right. So we're going to have to do it once outside the loop. And let's see.
You need all that outside the loop then.
I think you're right. All of it outside the loop.
But you don't need the iteration number, of course. Or
Yeah, right.
You just
All right. So that should be the first time. And then after that, we're going to replace that. We're going to say instead of func, we're going to use approximate, right?
yeah.
We're going to substitute, instead of guess, we're going to substitute approx. Because the approximate's going to be the next guess.
Yeah. Yeah, approximate an A. Yep.
There we go. Okay. All right. Let's see if that works a little better. I only promised to show you syntax, not logic. So I'm holding my promise.
Okay. Well,
All
I'm just reiterating when I used to run these programming groups
Yeah.
that you got one valid line of code a day, literally, out of a programmer. And that was our assumptions.
Hey, there we go.
Yeah, that works a little better.
The only problem is with the iteration I. Notice that it's 1, 1, 2, but that's an easy fix. So all we're going to do is we're just going to put I. We're going to move the counter up. So, all right, last time. This should work.
Okay, you got to put the counter in someplace.
Yeah, I'm going to move it up. So that way it does it before the computation and before it prints. Because it was doing post execution last time.
Okay.
All right. So what was the original function? We had was it sine x minus x squared?
Yeah, something like that.
All right. And make it a little more challenging this time. Let's say 1. Well, let's try 5. Let's see if it converges. Nope. Although it stopped.
It was still not behaving.
Yeah. It might be because the initial guess was too far away for it to converge. Does that have a 0? Yeah, it has to. Never mind. It really doesn't like that function. What was the one that we used before that worked? Let's use that one. It was cosine, right?
Yeah, cosine.
All right. Paul, I'm not using your function anymore. Sorry. I don't like it. Actually, MATLAB doesn't like it. It's not me. It's really odd. Let me try a further. Oh, I know why it didn't work with 5. Because it's not the 0 that we're finding with 5. Because it's probably periodic. And it probably has another 0 further away from 5 for that first one. I wonder if there's a couple solutions to that sine x minus x squared is 0. It's
Maybe.
bouncing back.
I mean,
It's probably-
basically, x squared starts at 0 and goes
Yeah.
up, obviously.
Yeah.
And then sine is a periodic function that never broaches 1. So there's got to be a place logically that these things cross over and one goes very negative
Mm-hmm.
versus the other.
Let's try this. Okay. All right. So it looks like it's working finally. So we'll go with this. I'll try EXP. I'll just try an exponential function just so we can try something different. Let's see. Come on. So let's try EXP of x minus, let's try minus x squared. And let's try 1. Oh, shoot. Well, that's probably going to get 1. I don't know why it's doing that. I wonder if the error was too large. If it doesn't work, I'll try to fix it because I do want to get onto the vector stuff, and I know we're running out of time, and I'm sure it's tedious to sit here and watch me try to fumble through the code. Let's try 4. Yeah. Okay. So I'll try to fix it up, and it looks like it's mostly working. It's probably like a logical error somewhere in there, and I'll just send it to you guys when it is fixed. So, all right, let me percent all this out.
Now, is there a way to do that without having to go through each individual line? Do you know?
There might be. If there is, I just don't know.
I think you can group comment at the top.
Oh, hey, Lisa.
Hi, I just got here. There's something at the top here. If you look at the top, there's like a percent, and a bracket. There's like an arrow. You see it? Next to comment under editor. Right
Okay.
there, insert, comment.
Oh, I see it right there.
Over.
So if you highlight everything, and
I think you push that button first or something, and it'll make a bracket and like comment out that. Go over, all the way over.
Cool.
Yeah, there's that. Or there's all the way over, like if you go over 2 buttons, you can make like
I see.
group, yeah, like a group comment out.
Wrap comments.
something.
Okay, cool.
That's helpful.
That's very helpful. Now
Oh, good. I got here just in time.
You really did. Thank
Yeah.
you. You also didn't watch me fumble and forget input like 6 times. That was fun. Oh, that was terrible. So, all right, give me 1 sec, guys. My other computer logged out, so now I have to log back in to get the problems. So, okay. All right, so we're finally onto the matrices and the arrays and stuff like that to be able to use in MATLAB. So just wanted to start by defining some pretty basic arrays. So first of all, an array, it's the same thing as like just a single line matrix. And we could define them with just spaces, or if you wanted to use commas, you can. All right, so when you're defining them, a comma separates the values. A semicolon inside the brackets will move to the next row. Okay, so that moves to the next row. Okay, so if you're starting to make a matrix, what I usually do is I just use spaces. Okay, so I'll also make the comment that spaces also separate values. All right.
Yeah,
so
they're called delimiters.
Delineate or delimiters. Thank you.
Yeah,
Okay.
that's what we refer to them as delimiters.
Cool. All right. So I'm going to define A as an array or the matrix. Let's just say 3, 6, 7, 9, 10, 11. And I'm going to suppress that. And I'm going to define the matrix B to be 1, 2, 5, 6, 7, 9. All right. And we just want to do some matrix operations with this, okay? So the first thing we want to do is to print the 4th element in the first array, all right? So if we want to do that, all we have to do is just say A parenthesis, I think it's 4, right? Not 3, because I think MATLAB starts index at 1.
Yes, no zeros.
Thank you.
For indices.
Oh, it starts at 0, Lisa?
No. You're right.
Okay.
It starts at 1.
Thank you. I thought so, but okay. So I'm going to run that, and we know that it should print out 9 if we do that correctly. So I'm going to print. And there it is. It tells us the answer is 9. So that's how you guys access the elements in the arrays.
Yeah, it's important to notice it's parentheses, even though the matrices is made with square brackets.
Yeah. All right. You want to add the two arrays and produce a new array. So let's say C is equal to A plus B.
As long as they're the same size.
Right. If they're, and we know that just from basic matrix algebra. If they're different sizes, it's not going to get that. So we should get 4, 8, 12, 15, etc. for letter C or variable C. All right, so 4, 8, 12, 15, 17, 20. So MATLAB does indeed do the matrix addition. All right, so I'm going to suppress these. Multiply all the elements in the second array by scalar 12. All right, so this is where it starts getting tricky between matrix multiplication and scalar multiplication. Now, we can't multiply matrices A and B, all right, because the dimensions are off. All right, it just won't let us do it. Remember, the rows and the columns have to be equal for us to do that matrix multiplication. All right, so we're going to do this. We're going to say 12, and then I think it's dot times B. I think you have to put that dot beforehand.
No, you don't.
It's afterwards, or
no, you don't have to use the dot if it's a scalar.
Right. Okay.
Yeah, that's correct.
It's only if you do vector multiplication by vector multiplication.
That's right. Okay.
Element by element.
That's right. Okay. So that just gives us 12 times every element in matrix B. Cube each element in the first array. So this is where we need to use the dot, right, to be able to cube each of those.
If you want to do it each element cubed, yes.
Yeah. So.
Yep.
Okay. So
and it's dot then operator.
Right. So that's going to be a dot cubed. All right. And what this does is this does element operation as opposed to matrix operation. And we know that we can't cube that matrix anyway. Right, so.
Because it's not.
Right, it's not the right dimensions.
Square.
It's not a square matrix, right. So there we go. It just goes through and it cubes each of the different elements within that array.
So sometimes we call them vectors.
Yep, that's true. They're vectors. Thanks.
So like a row vector, because it's just a row, and you can have column vectors that are just columns, and then you would transpose those. Right,
yeah. And to do that, you'd use semicolons instead of the spaces. All right. It says plot the two values as an ordered pair. Okay, so I'm going to plot. Now check this out. There's a couple ways. This is pretty cool. So I'm going to plot AB. And if we just do that,
yeah, I'm curious.
Right. That's going to give us a line graph of that. So I'm going to have to switch screens just to show you what that does. All right. So give me 1 sec. Well, probably more than a sec. So I'm going to have to do a new share. All right. So you guys see it basically gives you like a weird polygon out of that.
Uh-huh.
That's not what we want. Okay. So if we wanted it to be a scatter plot, what we're going to do is we're just going to change that third parameter. Okay, so I'm going to stop share and I'm going to go back and do this. So what I'm going to do is I'm just going to say comma, and I'm going to print out. So this is going to tell us what shape we want the dots to be in. Okay, so now we're going to get a scatter plot, and this O is going to dot plot. It's going to give us the plot of those. So let me run this again. All right, and it's thinking. Thinking it better give me what I want.
Yeah, it can do all kinds of, you can put stars or blocks or whatever you want.
And you can change
different colors.
Yep.
Yeah, you can change the colors. That's always fun.
Yeah. So this time we do get a true scatter plot out of this. If you want to change the colors, I think it's the fourth parameter that you change.
I think you can combine it with the marker in terms of you put like B star, and then that makes black stars.
Yeah, so let's try.
Actually, that'll be blue stars because black is A.
Right.
Oh, that's right. Thanks, Bill. I knew it was. That was going to be a guess.
And I think it's lowercase, right, for the letters. It's not.
Yes, it
yeah.
is.
And is it the color first and then the marker?
Yes.
Okay.
I couldn't remember.
I know, we're just getting to that section right now in my class.
Yeah, I got blue stars.
I got red circles. I'll share it with everybody.
You can do hexagons. I know
Yeah.
you can do it.
All
That's always
kinds
fun.
of cool stuff. Oh, so there we go. So for some reason you wanted to store a bunch of data. A lot of times what we do is we store them as vectors, or in this case, I just say arrays.
The issue we always have with these plots, though, as you can see, is that your last data points are hanging off the edge.
Yeah, I think
So
you can change the you can change the
That's
scale.
what we have to do usually, is change the axis.
It's a bit of a pain, but it can be done. So that's pretty cool.
Well, I think you actually have tools. You're using EasyPlot, right, to do that?
No, just plot.
Yeah, just plot, but there are tools.
Yeah, I think you can change the axis and the layouts and all of that stuff if you want.
Yeah, but when I regenerate the program, it won't change it.
Yeah, that's correct.
Right.
So you want to use figure or things like that, which is the way I do it, which is pretty old school.
Yeah, that's okay. Yeah, that's the way I do it too.
MATLAB is old school.
Yeah.
You're right.
Find the median, or we plotted the 2 points, and then find the median value of the first array. So we'll just say median of A, and that should find the median. It might be med, but
I was going to say, this is a function?
Median is the function. There's also average, which is the mean.
Yeah, that's what I was
you
thinking.
can
Average.
use mean. So if you wanted to find mean, you could find mean A.
Mean is not a function.
Average is.
It's average.
Okay. So it gave us the, let me try average to see if it gives the same thing.
Oh, it did give you an answer for mean. Oh,
Yeah.
no, that's the median. Oh, wait, that's the second one. Okay.
Yeah, so 8's the median, and then the average is 7.6667.
Right. And actually, there's an average. No, I guess that has standard deviation. You get into the.
Oh, look, average doesn't work.
Yeah. I know
So
standard.
maybe you're thinking Excel, Bill.
Could be. Could be.
Yeah, Excel doesn't have mean, but it does have average.
Yeah, I know standard deviation is STD. No jokes.
Yeah, I know. That's terrible, isn't it? I don't
Yeah,
think we
it
ever
really
did
is.
that in.
Could have done STDEV or something, but
That's what it is in Excel, DEV.
Yeah. it just makes a lot more sense. So, all right. So I'm just going to keep this, or get rid of that. So that's just some of the stuff you guys can do with the one-dimensional vectors. Now we can do stuff with two-dimensional vectors as well. So, so let's, letter B says, let's define a matrix as follows. So first of all, I'm going to define a matrix. Let's call it D. And D is going to be equal to 1, 2, 4.
One of the things that I think is unique about MATLAB with the vectors, Chris, is that you can put them together and just make a long vector too. Like, you know, you can just subset them into each other. So I think that's something interesting that MATLAB does, that it just automatically grows to fit whatever's in there.
Yes. Yeah, MATLAB,
And also, there's a library of functions that they have for vectors that is like insanely long.
Yeah. So I'm just going to go ahead and run, and just to show you what MATLAB does when you define this matrix as with the semicolons. All right. And notice what it does is it just gives you the matrix. Those semicolons push you into the next row. So it's not, it's pretty easy to program that. Okay.
Yeah, when I talk about it in class, I say it's like the typewriter and it's the end of the paper and you're going to the next row.
Yeah.
And then I see how many students know what typewriters are.
Now that's funny.
You see how many mistakes you make in the process.
Okay. And I do notice that on the sheet that I had, I said to store it in capital variable X. So I just changed D to X. So if you are coding along with me, just change that. All right, so now it's coded. So now what we want to do is we want to print out a few of the elements. Okay, so I want to print out row 1, element 3. So here's what I'm going to do. I'm going to say X1, 3. And then I also asked to print out row 3, element 2. So that would be 3, 2. So that should access the elements in the multi-dimension array. All right. And so notice that 1, 3 is 4, so that's correct. And then 3, 2 should be 5 or 3. There it is, right there. Okay. So that's how you guys would access specific elements in the array. All right. If you want to access certain rows or columns, you can do that as well. I'm just going to show you that really quickly. So you could do something like this. You could do X, you could do colon, comma, 3. Right? And check out what that does. That just tells you what the third column looks like. So the third column is 4, 1, 5, 0. So that's how you can access specific columns. All right. If you want to access a specific row, like maybe the second row, you could do X2 comma colon. Okay. And I'll put a comment next to that so that way when you guys are working on this for fun, because you have nothing better to do. Oh, capital X. That would be helpful. Sorry. Enough syntax errors today.
Yeah, so the colon is related to the linear sequencing, and it just means all the numbers in the row and all the columns. That's what the colon represents.
Thank you. So access all elements in column 3. And then this other one will access all elements in row 2. All right. So before I showed you that you can find the median and mean of specific rows or specific one-dimensional arrays or vectors. So now what we could do is we could find the average of, let's say, row number 4. Okay, so I could say mean, and we could say X, and we want to find just the mean of row 4. So that would be 4 comma colon. And if we execute that, that's going to give us 6 plus 7 plus 0, which is 13/3, which is 4.333. All right, so that's pretty cool. Check this out. If you just do mean of X, just to show you what that would do, it actually finds the mean of all of the columns, I believe. Yep. So notice that these 3 values, that would be the mean of column 1, column 2, and column 3 independently. Okay, so this first one is the mean of row 4. This is the mean of all columns. Find the standard deviation of column 1. So that would be STD, X, and we don't care about the row, we care about the column. So we're going to say colon, comma 1. And we're just going to run it. All right, and there we go. All right. I don't ever use this for my statistics courses, but certainly in data validation, all right, finding a standard deviation, especially if you have a huge amount of data that's stored in a multi-dimensional matrix, could be very helpful to be able to find some of these statistics for it. Okay. All right. So Lisa, did you have anything else to kind of add to any of the basic access and operations of some of the vector stuff or matrix stuff?
I'm trying to think in terms of what we normally do is we access the indices, and then like you're doing with the colons would give you the whole thing. I know you're not going to do any adding, multiplying, or anything like that with the matrices?
No, not today. I was going to do some of the matrix operations next time.
Okay.
But just
Yeah, I think that's a good intro to how to access the individual elements of your matrix. You're just the rows versus the columns.
Cool. All right. So now what we're going to do is we're going to request that the user input a list of numbers that are enclosed within a bracket. And then the program's going to do a few things. It's going to find the size of the matrix or the sample size. It's going to find the mean and the standard deviation of that list. Okay, so let's just call a variable, let's call it P now. P is going to be equal to, I've learned my lesson finally, input. It's going to be the running joke for the rest of the year. So input, let's say, enter a list of values enclosed in brackets. Okay. All right. And then what we can do is now we can go ahead and find the different variables for this. So now check this one. I'm going to do this one. So we're going to do size of P, and I'm going to show you what that does. It's not going to give us the right output, but I'll show you what it does. And then mean of P.
Is size this? Oh, this is a matrix, right? So it's not,
Yes.
because length would be the one you would use for a vector.
Right. So I'm going to show everybody what size does, then I'll show, in fact, I'll just type them both in. So length of P, size of P, mean of P, and then STD of P, not TED. All right. So let's just put in a really basic matrix. Okay, or I'm sorry, a basic list. So let's just say 1, 2, 3, 4, 5. Because we already know the median and mean are both going to be 3 for that. All right, so we're going to execute that. And I'm going to have to scroll up a little bit because I didn't. Okay. So now check this out. So the size gives you 1, 5. Okay. So there's when you use the command size, there's actually 2 things that it does. The command size will give you the column, so that's the number of columns, or I'm sorry, the number of rows first. And then the second parameter would be the number of columns. So size is better used if you do a matrix as opposed to a vector, right? But if we do length, like Lisa suggested, you get 5 out of that, which is indeed the length, the number of elements within the vector, right? And then we know that both the median and the mean are both 3, although we just asked for the mean. And then here's our standard deviation, 1.5811. What I did this. I did P colon, and then I think I just did 1 comma. I think I might have done the colon. And I think that might work to be able to get the size. I don't know. Or maybe P comma 1, but I'll see what happens. This is more out of curiosity than anything. It still did the same thing, 1, 5. So we'll just keep it like that. But these are just some things that you could do, like if you want to just freehand enter things. So let's say for some reason you don't have Excel available and you needed to find average of some student work or something like that, or even if you wanted the students to write their own program to be able to find the average of a list of numbers or some other stuff, this could be a good way to interact with that. It's really cool, I think, if you wanted to do like scatter plots and you wanted to do a number of different scatter plots, you could have the students enter those instead of hard coding them within it. So
yeah, when we use an example similar to this with a loop, where what they do is they have you enter a vector of values, and then through the loops you sort it into negatives and positives.
mm-hmm. Yeah, that's really cool.
And then you use the length to figure out how many elements you have, and then every time you go through, you use an element, to separate it out, a counter.
Lisa, do you know if there's a function that sorts, like sort P?
I don't know. I don't think so, as far as I know. But there may be one that pulls out like the negatives or pulls out the positives, like it extracts them.
Right. And
Or
you
tell you how many negatives or how many positives.
Yeah. And you could do that with like a for loop, like you said before, but yeah.
But I don't know what sort. I'd be curious what sort does.
I have a feeling it's going to give an error, but let's try it. Let's see what sort does, if anything. So let's just try.
It puts them in ascending order, it looks like.
Yeah, there it goes. Cool.
Yeah, that helps.
Yeah, that actually is pretty cool.
That
So
looks
there we
like
go.
we have bubble sort working there. That's good.
Yeah. Yeah, it's probably the most efficient one. So it sorts a list in ascending order. That's pretty cool.
Yeah, it'll do the same with a matrix, but
Really?
Yes, well,
if you specify the row, though, I think
Oh,
it'll sort the
okay.
row.
So if we did like sort, if I go back up here and do sort of X of 1 comma or like 1 colon. Let's see if it sorts.
And it'll do characters alphabetically.
Oh, cool.
And if you put descend on the end, you can put it in descending order.
This one was already in order.
That's pretty cool.
Yeah,
Yeah.
I've never used that sort before.
No, I used to write programs that did that kind of thing. So
Yeah.
really cool that you can do it.
I agree with that. That's fun. Oh, I have to enter a list. Sorry. MATLAB still hung up on me trying to do the last thing. I tried to do the sort on the second row, and it actually did it. So if you look at 461, I just wrote this little line of code that actually sorted it. So Bill, all that bubble sort and what is it, the linear sort that you've done, the bucket sort and bubble sort, that's all worthless now.
Yeah, yeah, somebody already did it for me.
Yeah, I know.
That's
But it was
okay.
fun at the time. Okay. All right, the last thing I wanted to show you guys was to be able to utilize these vectors to be able to plot functions. And this is the way I learned when I used MATLAB, was for the easy plot function. This is how I learned how to be able to do these vector operations.
Yeah, before you get into that, here's another one that I've been using in the linear algebra class. Norm.
Oh, okay.
If you got two vectors,
Oh, yeah.
it'll tell you the distance.
Oh,
Those
okay.
two. And they can be
Vectors?
individual vectors, by the way.
The norm of AB.
Yeah, the norm of yeah, it would be the norm of yeah. It's a distance, basically.
Yeah. Well, that's pretty cool. Oh, it's still hung up down here. Sorry, I didn't parenthesis out or percent out the other stuff.
The other one that's pretty good is if you have to do dot product kind of stuff.
Oh, okay.
Dot works also. It's a
Oh,
function.
dot. Yeah. I teach that in my Calc 3 class. They can do dot, cross.
Yeah, dot and cross and those kind of things. Yeah.
Yeah. All right. So let me show you guys how to utilize MATLAB to be able to plot. So it says create an array X such that X spans from 0 to 10 in increments of 0.1 or 0.01, excuse me. And then we're going to graph 3 functions, sine X, sine square X, and then sine 3X on the same axes. All right, so here's the way to do this. We're going to say X is going to be equal to 0 colon 0.01 colon 10. Right? So what this does is it has 0.01, 0.02, 0.03, all the way up to 10. In fact, I'll just run it and I'll show you what happens.
A lot of numbers.
Yeah, it's exactly what it gives you. So notice what it gives you. It gives you all the elements and it tells you all the, so that's right now what's stored in X. Of course, we're going to suppress that because we don't want that, right? And then what we're going to do is we're going to plot the functions, okay? So we're going to say Y is going to be equal to the sine of X, right? And we're just going to plot X comma Y. And I know I said to plot all 3 of them on the same graph, but let me just plot this one first, just to show you what happens.
And not F plot?
Nope, just plot. So I'm going to, let me share the screen because you guys can't see it. Sorry. Not surprisingly, you get a sine function. So there it is. So, and notice that the bounds go from 0 to 10. So I didn't put the axes on there or anything like that. So that's pretty cool. Let me back out of here. Now, if you guys remember, we could use that hold on. Yeah, literally that hold on function. So we're going to plot X, Y. And I'm going to make some different variables. So we're going to say hold on. And I'm going to say Z is going to be equal to, now we want sine squared. So Z is going to be equal to sine of X quantity square. And in fact, I could probably just do this up here. And we're going to plot X comma Z. Hold off. And then we're going to hold on one more time. And I'm going to make a third variable. Let's say A. A is going to be equal to the sine of 3 dot times x. I think we could just do 3 times x, can't we, guys?
If it's just a constant times, yes.
Yeah.
If 3 were a vector, then you would need the
Right.
dot.
Yeah, we don't need that. Okay. So
But
we're
if you
gonna
were
put that-
doing like x dot y,
Yeah. And hold on. All right. So, and I got to suppress these, otherwise we're going to get an enormous amount of data that's just going to show up there. That means nothing. Run it.
hold on.
I think I need a dot after that square.
Oh, you do?
Yeah, because it's squaring each.
Oh, yeah.
Okay.
That
So I
makes sense.
wonder if it's going to ask me to do the same thing. Probably not with the 3.
Oh, wait, it's sine x squared. Oh, okay, not sine x squared.
Right.
Sorry.
Okay. So, let me share this with you guys. I've got a pretty interesting graph.
I have to add more
correct.
parentheses.
But let's see. Sorry, guys. I've been looking at the computer screen for about 5 hours straight. So there we go.
Ooh.
So it's pretty interesting. Bill, if you took that to your digital logic class, they might be able to find something cool to do with that.
Yeah, maybe.
Maybe not. Probably not.
Color it in.
Yeah, exactly. You could tell them at pi, it all looks like they're coordinating with one another.
Yeah, that's right.
That's about it. So maybe something special happens around pi, but other than that, not really all that cool.
Maybe
All right.
number 2 also. It looks like something's happening.
Yeah. Oh, yeah. All right. So I think that's everything. So any final questions I can answer for anybody about anything before we depart? All right. So I do thank you guys for suffering through my stupid syntax errors. Sorry about that. But at least I know from now on use the input function. It's usually helpful. And then the next session, which is the last one, we're going to do a little bit more with matrix algebra, and then we're also going to explore some of the differential equations, like the ODE 45 function, to be able to numerically approximate some of those solutions. So that'll be a lot of fun. I'll learn how to do my syntax a little bit better by then. So I will see you all. I hope you guys have a great weekend, and thanks again for attending. So any other last thoughts from anybody?
Yeah, I just need to talk to Lisa for a minute, but maybe we can do this after this call here. So.
Okay. Cool
Okay,
deal.
thanks, Chris.
All right. See you guys. Bye-bye.
Bye.
Thank
Yeah,
you.
thanks.